everyone. Welcome back to SAT Math Question of the Day with the Brothers Chaiken, where we try to show you how to show you some approaches on studying for the SAT and approaches to doing SAT math questions. Here we have Seth Chaiken, PhD in math. He's a professor emeritus at the University of Albany, and Joel, I have a PhD in mechanical engineering. We come from different perspectives, so often we have different approaches. A wonderful approach to studying for the Math SAT is to get yourself a Khan Academy account, or just Google Khan Academy SAT practice, and you can choose one of two courses: the regular SAT, the written one, or the digital one, which will start in the winter of 2024 in the United States. So what we do is we go through the practice questions. We only do the advanced questions because hopefully with all the talking we do, we give you approaches on how to do the advanced questions so you could do the mediums and foundations yourself. We plow through one question a day. Tomorrow is a rough day. I'm not going to be out. You'll see, hopefully location will be different. So tomorrow we usually do Throwback Thursday. Tomorrow's Thursday. Yeah. We're going to do Throwback Thursday today. I hope it doesn't upset too many people. But today we're going to do the pre-2016 question, which will give you a sense as to what the SAT looked like before 2016, before they told you exactly what was going to be on the test, and when it was more of a reasoning test, as opposed to a test of what you learned in school. So we are at this advanced math thing, operations with radical expressions, I think rational expressions. We did that yesterday. So today we do nonlinear functions, and here we go. The first question. Let's wait for the left. Oh, that's interesting. We must have done one or two of them already because it didn't say less.
Joel, the screen isn't shared.
Oh, thank you, Seth. Oh, my goodness. Thank you. Thank you for that. Okay, is the screen shared now?
Yeah.
Okay, I'm sorry about that, everyone. We have to share the screen. Wow, look at that. So we must have touched on these. I don't remember because you see how we... What is this? What is that? Oh, okay, let's go. Let's start again. Uh-oh. We got... Okay, good. Okay. Otherwise, we would run out of page. Okay, so here we go. Nonlinear questions. Our first one. Nonlinear functions advanced. So please try it. Do it yourself. And come back, pause it, come back, and we'll do it together. Okay, here we go. Time to do annotation. Oops, what is that? Come on. Sorry, everyone. Annotate. Okay, here we go. The graph here, f of x plus 5 is shown for which value of x, rounded to the nearest whole number, must f of x equals 0. So this is not just nonlinear functions. This is also function notation and understanding function stuff. If that's, they want to know what f of x is, right? So
okay. The tricky part of this question is that the x here and the x here are used differently. Okay. The x here refers to the x in the graph, and that what is plotted is y equals, let's call it g of x.
Yeah.
Which is f of x plus 5.
Right.
And now they're asking you to figure out something about f.
Yeah.
Some unknown quantity, so that f of that unknown quantity equals 0.
Right.
So what you might do is, so that is the tricky part of the question.
Yeah.
Now, here's how I would solve it.
Okay.
I'm interested in, well, what I know is that f of x plus 5 equals 0 when x equals minus 4.
Right.
That's from this spot here.
Right.
Yeah, because I plug in minus 4
Right.
for the x, I get f of whatever my f of minus 4, whatever minus 4 is plus 5 equals 0.
Right.
So now we're interested in what we're wondering, not what x plus 5, not what x is in this equation, but we're interested in what the whole question mark is.
Right.
When the function of the question mark equals 0.
Right.
Well, this is 0 when x equals minus 4.
Right.
So you plug in minus 4. And of course, minus 4 plus 5 is f of 1.
Right.
So f is the property that when you evaluate it at 1 is 0.
Right.
So the answer is 1.
Right. Yeah. That's a nice, clean
And you don't
way.
have to round it because the graph shows pretty clearly that. Well, I don't know. It's as to the precision of the graph. The value of x in the graph, where f of x plus 4 equals 5, f of x plus 5 equals 0 is minus 4.
Right.
So we don't have to round it. You just calculate minus 4 plus 5, which is 1.
So yeah, it seems like in this type of problem, if you really are stuck and you don't know what to do, maybe it makes sense just to play with it and take a chance and write f of negative 4 equals 0, right? And that's equal to f of x plus 5.
No.
Wait, that f of negative 4 is equal to 0.
You're falling into the pitfall.
No, that's right. No, you don't say that. You say
that's right. Yeah,
that's right.
Pitfall.
That's right, dude. That's the pitfall. You write
f
of x plus 5 is equal to 0. You write
yes.
that. That's true. That's
true. What I wrote.
And
the f of x plus 5 equals 0.
F of x plus 5 is
has
equal to 0,
a solution.
Right.
That you could read off from the graph.
X plus 5 equals negative. No.
Yeah, please, I will say what I said again. What you wrote in black.
Yeah.
F of x plus 5 equals 0. Has a solution in x.
Right.
For x.
Right.
That's visible from the graph.
Right.
That solution is x equals minus 4.
Right.
So that means that if you replace the x in black by minus 4,
right,
the replaced expression equals 0. So just write underneath there f of
minus 4 plus 5
is
equal
to 0.
So that's equal to f of.
Now, when you see that, it tells you a number such that f of that number equals 0.
Right.
And what's that number?
1.
So the answer to the question is 1.
So now let me offer another approach, which think gives the same answer, which may be familiar to a lot some people. It has to do with transformations of functions. Right now,
Oh,
I can speak for myself. Let's see if Seth confirms this. But I never remember the obsession in the school curriculum with transformations of functions. I don't
oh
remember
yeah,
learning that stuff. I don't remember ever learning that, like, obsession, like if f of x is equal to the absolute value of x plus 7, x plus 7 minus 2, right? The obsession with, well, the way you do this is you go down 2, but this is a plus 7, so you move it
yeah,
this way 7, you get the answer. I don't remember ever really learning that, but apparently it's big in the curriculum. So you could do this problem that way. If f
yeah,
of x plus 5 is shown, then I'm going to change color. Then that means that we want to look at what f of x is. But f of x plus 5 went this way. So f of x is this way, right? If this would be f of x, because f of x plus
yeah.
5
Except
moves it
that
in the negative direction
yeah, yeah.
this
Except
way.
that the that green curve crosses the x-axis at -1, not -2.
No. It crosses it at 1. I'm just being messy. It moves a
Yeah,
5.
well, I meant 1. Yeah, yeah. It
Yeah.
crosses it at 1.
That,
Don't be messy.
okay, fine. I'm making it so big.
Yeah,
But
yeah,
we know it's 5. We know it's 5. So you go negative
yeah,
4 plus 5 is negative 1. And you get the
yeah,
answer
yeah,
graphically using transformations of functions, which is
yeah,
taught.
yeah,
Now, Seth,
yeah.
were you over taught? Were you taught this transformations of
Yeah,
functions
yeah. I was
stuff?
taught that. Yeah.
Really? Yeah, I know. I never really remember it. I never really remember learning that stuff. Um, how to
I
and it,
was taught it. I was taught it, but I have to think twice about. I have to think twice before I have in my mind the which direction it goes.
yeah, because it's the opposite of your
It's
intuition.
yeah,
It's
yeah,
the
yeah. So
opposite of your
if you have
intuition.
f of x, if a curve, yeah, I'm doing it right. Yeah, yeah, yeah. Have your f of x curve,
Right.
right?
Oh yeah, Seth's drawing
F
on the
of x.
bottom. So you know people see it. It's on the bottom left there.
Yes, over the bottom f. Then, if a is positive, let's say a is this length.
Right.
Then the curve shifted over to the right by a
Hmm.
has the formula f of x
Minus.
minus
Minus
a.
a. Right.
And the way I remember that is that uh, that if say this point here is 0,
Right.
x equals 0. Uh, when I look at f of x minus a, when x equals 0, f of no sorry, when x equals a, when x equals a, f of x minus a equals f of, well, when x equals a, x minus a is 0. Okay.
I don't know. I just
So
remember
that's
it
how
as
I
the.
remember the rule that to shift the curve to the right by a positive amount, you give the formula. If the original formula is f of x, you The new formula is f of x minus a.
Yeah. It's just the opposite. I mean, but the
Yeah,
x, the a has to be inside the f. It
yeah,
has to be
yeah.
no, it has to be inside the f. It has to be inside the f, not outside the f. Inside the f. So the way I would have done this problem is I don't know if I would have done it Seth's way. I may have done it the graphical approach. But if you're familiar with the graphical approach, I would do it Seth's way, but then confirm it with the graphical approach. Because this is a really dangerous, confusing problem, because you could fall into this trap that I almost fell into, but I got saved because I realized once I wrote it, it was wrong.
Well, I was worried about falling into this trap, and so instead of thinking the tricky, the subtle, tricky geometric significance, what I did was avoid the geometric significance, and my approach was to use algebra.
Yeah, but algebra is potentially very, very confusing. Like you could fall the trap I did. I would try
an approach to studying for the SAT is to learn and to understand algebra better, so it's not confusing.
Right. Okay, let's see how they do it. And then we'll move on to Throwback Thursday. I hope they did it. I wish they would do it both ways. But let's see. So the answer we say is 1. Okay. Good. And let's just go through all the hints.
They agree with us.
Well, okay. Let's see. Let's see how they do it. Okay. Drum roll. We know that the graph. Oh, look at that. They did it my way. They did it the way I use. They did the graphical approach. Because
so they use here. You have to. They apply the rule.
Yeah.
That shifting. Let me scribble.
Okay, go ahead.
Shifting to the left. To the left is obtained by adding.
Right.
Adding how much the shift is.
Yeah. Now.
So if shifting to the left by a positive amount is equivalent to shifting to the right by a negative amount.
Oh, don't confuse everyone. Just don't confuse everyone.
Yeah. This requires that shifting to the left is done by adding the shift amount to the x. How do you know that? How would you remember that?
I'm
an
engineer. I'm an engineer. Just keep this thing. Just plaster this in your head.
Yeah.
Just plaster that in your head.
Yeah.
Down 2 over 5. It's a plus 5. Just have a really good example of this thing in your head, and then just go for it. Rather than remember
an engineer approach also is to verify that when x
Seth, you're not
equals minus 5, this gives you the minus 2.
Yeah, but you don't verify when you're taking the SAT. When you study, you verify. Absolutely, that's the approach to studying. Studying, you study this and you understand why. But once you've proven it to be true, don't verify the SAT. Now, if I did this problem this way, I never had a chance to do it because I did it, but I knew the answer. I would have double-checked and triple-checked myself because everyone probably knows by now I get my left and my right, my plus and my negatives confused, messed up, maybe some issue there. So I would have done this problem like 2 or 3 times, making sure.
Well, if you have trouble with left and right, then learn to do algebra.
No. I have trouble with left and right, so I do the problem 2 or 3 times. Quickly.
Well, you make the same mistake 2 or 3 times.
I really think about it. I think about it. Yeah. But I don't know. So they did not use the algebra approach. Look at that. Look at that. They did not use the algebra approach. Wow, look at that. Okay, everyone.
Wow.
So we're
Is
on
that all they said? Yeah.
Yeah, that's it. They used the graphical approach. But
Okay, good.
so
Good for them.
Everyone got it.
Good for me. I like my approach.
Okay, that's good. Okay, next question we do weeks from now when we cycle through all these questions. We do one question a day, we cycle through, and then we start again. Okay, Throwback Thursday on Wednesday. So let's clear the clear all drawings. Oh. What's that? Oh.
We did that already.
Yeah, I know, we did that already. Come on. Ah, wow, look at that. It worked. Here we are. Throwback Thursday questions. Seth, again, you probably have more of a brain than I do today. So, but let's see. Something tells me that you're going to be plussing and minusing a bunch of stuff. Okay, this is see, pre and post, I got it wrong.
Oh,
Pre-2016. This. I don't think this topic's on the test anymore. Good luck, everyone. Here we go. Try it out. Just pause it and come back for a Throwback Thursday. Okay, and am I annotating? Okay, here we go. The first 5 terms, 1, 2, 1, -1, -2, shown above. After the second term, each term can be obtained by subtracting the previous term from the term before that. Wait, so let's just, can we do one? This is an example. Each term can be obtained by subtracting from the previous term, the term before that.
Okay.
So
okay.
Wait.
So let me do systematic. Here's a term. Here is a term. Okay. Here is a term that is after the. Here's a term that is after the. Here's a term that is after the second term. Okay? The previous term is this one. And the term before that the word that refers to the previous term. So, and then it says subtracting from the previous term.
Right.
What is the previous term? Subtract from it the term before that, which is the previous term. And 2 minus 1 minus a 2 is equal to -1, and we verify.
Right.
Similarly, -2 is -1 minus +1, which it is. This -1 is equal to -2 minus a -1, which is 2 plus 1 is -1. Okay. Well, my approach to this comes from, learning, say, more advanced math.
Forget it. Don't use it.
I would write.
You can't use Stop with the moments math. Look at it from the point of view of someone in 10th and 11th grade. Forget about the advanced math stuff.
Yeah.
Do it that way, because it doesn't help anyone to do it the advanced math.
Oh.
It doesn't help us. It doesn't help people. So I'm just doing brute force. I'm just going through.
Does the thing repeat?
Look at me. Unless I made a mistake, it seems to be repeating, right?
Oh.
Doesn't it seem that way?
Yeah. Yes.
So I'm doing brute force engineering. Wow, look at this. And then if this comes in, then this is going to start. Then presumably, okay? Presumably.
Exactly.
Presumably. The next one is -1, -2, -1. By the way, Seth, I would love to hear your advanced method approach after we're done with it using the
Okay.
regular way.
Okay, good.
So
No, really cool. Yeah, what you did was you just realized that this rule gives a pattern, and the pattern is, the sequence is what's called periodic.
Yeah. I have to get the approach I did was I have to get a feel for the problem. If you don't know what you're doing in a problem, get a feel for it. Play with it. Try things out. Did I know this was going to work? No, of course not.
Yeah.
So now what does this add up to? Notice these go up by 3. They're pairs of 3. And 36 is a multiple of 3. Gotta make that right. 36 is a multiple of 3.
So it's also a multiple of 6.
That's right. Oh, yeah. So
what I see. What does
this add up to?
What I see, Joel, don't cross out. No. Okay. What I see is that the first 6 terms
0
are repeating.
Right.
And the thing is, the rule determines the next term from the 2 previous terms.
Right.
So whenever you start with 2 adjacent terms, the rest of the sequence after is determined.
Yes, I know, we know
and
that.
And so I see that these 2, the 1, 2, we discover by brute force repeats. And because the next term is a function of the 2 previous terms, it's going to repeat this way forever.
So, it's so clear that this repeats. Just keep this.
Yeah.
You don't have to go through all this explanation.
But no. What I'm doing is proving that it does repeat.
You don't have to prove anything. You just look at it.
So how do you know? You calculated 1 to 1, right? How do you know that the next term is -1?
Because this is a 1 to 1 here, and we've already done the calculation. We already know that after 1 to 1, the next term has to be a -1 because we did the calculation here.
Yeah.
So we did the calculation there.
Yeah.
Plus, you gotta
well, so my point is that the next term is -1.
Yeah.
To know the next term is -1, all you have to do is recall the calculation involving these 2.
That's right.
Not all 3.
That's right. Absolutely, of course. Okay, so we actually have the answer to this question. Let's see if we're right. 22.
We are right, but let's see if they agree.
Don't be so smug.
I'm not smug.
Mathematics, section 1. Question 22 is A. Oh my God. Difficulty level 3. By the way, what would you say the difficulty level of the last question we did? The f of x plus 5. What would you say that would be? I would say difficult.
Yeah.
Yeah, I would say.
What's the range of levels?
Oh. That's so smart. Oh my God. 1 to 5. Oh well, on this thing, 1 to 5. Yeah, the SAT people used to actually tell you what difficulty level. Maybe they do now too.
I don't know.
But anyway, this is
compared with the SAT questions of the current corpus.
Yeah,
I think this would be a 5.
Yes. That's no question. This would be
they made it easier.
The test. That's right. They made the test easier.
Yeah.
Ooh. So maybe. Ooh, look at that. Question 23 is a 5. So maybe next week we'll do question 23, which we'll do next week. So we look forward to. Okay, Seth. Now's your chance to be an advanced math person. Go for it. How do you do it if you're an advanced math person? Do you want to torture us with this? Your answer?
No, I don't.
Okay, that's fine. I'm totally fine. No problem. Okay. So I guess we're done with Throwback Thursday. Brute force. Play with the problem. Play. See what happens. Take a chance.
Yeah.
Have some confidence that eventually you'll figure it out. Unfortunately, you have a time problem. How much time did they give you for these problems? The old SAT had section 1, 25 questions in 30 minutes. So they expect you to do this in about a minute. On average. 25 questions in 30 minutes. So. Okay, everyone. So I guess that's it, right? Throwback Thursday.
Okay,
Not
that's
even
it.
though it's
Yeah.
Wednesday. Tomorrow we just
Yeah.
do a regular thing. I'll be out in the field somewhere.
Okay.
So have a great day, everyone. Please like us, dislike us, give us comments on YouTube videos. And if you have any questions, SAT math questions, please email them to us at satmathquestion@gmail.com. Keep studying, keep doing con, and keep doing practice tests. Take care, everyone. Have a great day.